Okay, so for this video, I'm going to talk about and go through some of the changes between physical and chemical changes. I'm also going to cover physical and chemical properties after. Okay, you will be doing a lab on these topics, and you always be trying to figure out in any lab, is a physical change occurring, is a chemical change occurring, as well as any kind of observation that you make is either going to be describing a physical property or a chemical property. So it's important that you understand the vocabulary and the differences between the two. So here we go. A chemical change is any change that causes one material to turn into another. A chemical change is going to have a really obvious, it should have a very obvious, way for you to determine that with your eyes, with your senses. And at the atomic level, you are breaking bonds and forming new bonds. You're not actually seeing that process occur with you're not seeing the individual atoms, but you are seeing the result of that based on the signs that you see. So some example is when you burn something, okay, that is a sign of a physical change, okay? Rust forming on a bicycle tire or wheel or on some piece of metal that's been left out wet. And that's a chemical change. There's actual atoms rearranging, new substances being formed. A rotting apple. Okay, you got that color change. It smells, doesn't smell as bad, as great as it did. That's a chemical change. Decomposing, growth. I mean, your body is a hub for chemical changes. Okay, you're growing, changing. Those are all chemical changes. Okay, a plant growing out of the ground, that's a chemical change, and so on. A physical change is something that where substance changes its appearance, but not the chemical composition of a material. So you're not changing it at the atomic level, just how it looks macroscopically. So some examples of that. Phase changes, that's a vocabulary. Okay, phase changes are states of matter changes. That's when, so say you have a piece of ice, solid water, and you're going to melt it. So going from a solid to a liquid here, that is a phase change. So if you take ice and you melt it, it was still water when it was ice, and it's water now in the liquid phase. So water is water. It just changed states of matter. If you then go on to boil that water, so say you now want to heat up that ice to liquid water, and then you want to boil off that liquid water, taking liquid water and boiling it to gaseous water. Again, it was still water in the liquid phase, it's still water in the gaseous phase. You're not actually changing the water chemically. It was still water before, it's still water after. Okay, so any kind of phase change, we'll talk about this extensively throughout the year. It is a physical change. All right, some other ones. If you bend something, bend a sheet of metal, bend a piece of paper, yeah, you're changing its appearance, but it's still whatever that substance was. When you dissolve something, okay, this one can be tricky because sometimes this is in the heart. Dissolving will show other signs that it's not just dissolving, it's reacting. But like if you put sugar in water, it's just dissolving. The sugar was still sugar before, now it's just wet, okay, and it's mixed in with water, but the sugar molecule hasn't changed. Okay, if you rip a piece of paper, it's still paper. Yeah, you've made it less useful, but you haven't changed it chemically. Now, if you go and burn that piece of paper, well, then you've changed it chemically. You've actually broken bonds and formed new ones. If you smash something, so on and so forth, that is a physical change. At this point in the year, a good rule of thumb is that if something can't be changed back into what it was before, it was probably changed chemically. So if you look at something and you're like, I don't think I could get it back to what I had before, then it probably bonds were broken and new bonds were formed. Now, a little bit more concrete. These you need to know. You just got to know them. I should show you a video later this week, if I haven't already, about the 4 signs of a chemical reaction or chemical change. Those chemical reaction, chemical change, interchangeable. You need to know these 4. Okay, so the first one is a temperature change, higher or lower. So say you mix 2 things and the temp spontaneously gets higher, or you mix 2 things and the temperature gets lower. That's a sign that a chemical reaction has occurred. If the color change occurs where a color was not previously present, so say you had some blue crystals and some clear crystals, you mix them together and they turn green. Okay, that's a chemical change. But say you had yellow crystals and clear crystals and you mix them and it's just a lighter yellow, that's not a change because the yellow was present before. So a color change is where that color was not previously present. A precipitate being formed. This is a new vocabulary word. Make a note. This means that a solid was formed. Okay, a precipitate being formed is where, say you mix 2 liquids, and when you mix those 2 liquids, it gets cloudy, or a solid is formed from the mixing of those 2 liquids. Precipitate is just a fancy scientific word meaning a solid forming when there was not a solid present previously. And often you'll also see a color change when a precipitate is formed. And they usually kind of make a liquid thicker and denser than it was before. And the last one is a gas being evolved. Okay, not like a gas being spontaneously made. Different than just being produced. So if you go and take liquid water and boil it on the stove, you will make a gas, but you're adding energy to it. Like water, in order to make gaseous water, you have to heat it up. Okay, that's not what I'm talking about here. It's like when you mix 2, like a solid and liquid, and you start, you hear fizzing or you see bubbles. Okay, that you're not putting any energy into it. That's a gas being evolved. So if you ever had an Alka-Seltzer tablet and you put it in water, it's going to start bubbling and fizzing. That's a gas being made. Okay, so that would be a sign, a clear sign that a chemical reaction has occurred. And you only need one of these signs for there to be a chemical reaction, but you can have one or more. You could have all 4 occurring, and that would be 100% a chemical reaction is occurring, but you only need one, okay? And then you can know for certain that a chemical reaction has occurred. If none of these have occurred, and you do not have a chemical change, you have a physical change. So here's a nice summary chart. You could pause the video, make notes of this. A couple more vocabulary words. So evidence for each type of change, a chemical change. This is kind of going through a little bit more like the temperature. So process is spontaneously exothermic, meaning the temperature increases, it's heating up, or endothermic. So endoexothermic, heat is being absorbed. Those are some of the scientific words we talked about for changes in temperature. So exothermic is hot to us, and endothermic is cold to us. Something feels cold. You get the color change. Here's this nice definition of a precipitate, and it also has here a chemical and physical properties of the material change, because you're forming a new substance. Versus physical change, you got no spontaneous change in temperature, usually no color change, no precipitate, and only physical properties of the, and so now we're going to talk about what are those physical properties and chemical properties. Okay, so how you describe a substance, properties, you're not actually changing them, it's just descriptors. These will help us better understand the differences between chemical and physical changes. So, start with the chemical property. That is any characteristic that gives a sample of matter the ability or inability to undergo a change. So chemical property is going to describe how something could change without actually doing it. It's typically listed on a label or something that you would know about a substance of how it could change. So if you hear something is flammable, okay, meaning it has the ability to burn, okay, or if it's combustible, that's another word. That's telling you a chemical property. It's telling you something about the substance of how it could change. Something's flammable means it can burn, and if it's burning, then it's changing chemically. One that you'll learn more as the year goes on, and if you study chemistry more in depth, like go on to AP Chem and whatnot, resistance to acids. Okay, so if something doesn't react with acids or isn't changed with acids, that's describing something about that substance. If it tells you how reactive something is, okay, with water or something else, that's describing a chemical property, how it can change. Okay, a couple more. So it's, again, how a substance acts or interacts. So it'd be flammable, combustible. If something is described as its ability to rust or rust, but it has not yet done so, again, it's a chemical property. Reacts with, so those are just some other words that could be used. Oh, okay. A physical property. It is a property that can be observed without changing the identity of the substance. Anything that you can observe with your five senses of a substance before doing anything with it is a physical property. And some of these properties, okay, are describing physical properties of that substance. So like a melting point or boiling point. Remember that phase changes. If you melt something or if you boil something, that's a physical change. So if you know its melting point or boiling point, then that is a physical property of that substance. Every substance has its own melting point and boiling point, okay? Same with color. If you describe something as blue or purple, then that's a physical property. A smell, okay? How attracted or repulsive something is to magnets, okay? Ability to, if something is magnetic or not. Viscosity, that's probably a new vocabulary word. You can think of that as how thick or thin a liquid is. A good example would be like comparing water to honey or water to molasses, like the flow of a liquid. So water is a pretty thin liquid. It flows very nice. It has a low density. You could also, like, density is a physical property. So how viscous something is how thick a liquid is, generally. So honey would be considered very viscous, has a high viscosity. Um, Solids, you could talk about hardness. I mean, not all solids have the same density. If you think about something like a blanket, that's a solid, but it's not very hard, it's soft. Okay, so versus, a hunk of metal could be pretty dense. Solubility, that might be a new vocabulary word for some of you. That is how able something is to mix with something. Now, it's not talking about reactivity, so it's a difference. So solubility is just how well something mixes with water, typically. So like oil, you would say, oh, that's not soluble in water. It doesn't mix with water. Versus sugar or salt. Those are soluble with water. That's a physical property of those substances. They're different, okay? Not everything mixes with water. Not everything is soluble with water. And then density again. How thick, how dense is a subject to physical property. Yep, states of matter. So if you describe something as a solid, liquid, or gas, whenever you're in the lab, you're doing an observation, you want to describe your substance's states of matter. MP and BP are those melting point and boiling point. You might see them abbreviated that way. Soluble versus insoluble. Ductile could be a new vocabulary word here. It's describing a physical property. Ductile is the ability for a metal to be drawn into a wire. So if something is ductile, it can be made into a wire. Versus malleable. Malleable is also another property of a metal. It's how bendable or flexible that metal is, or its ability to be flattened into sheets. So again, not all metals are ductile or malleable, but ones you see used regularly, like copper. Copper is very ductile because it can be drawn into wires, and iron's very malleable. So, but not like all metals are. And then density is a physical property. So here are a couple example problems that I'm going to just kind of talk through so you kind of get an idea of what types of problems you might see applying physical and chemical changes in properties. So milk turns sour. Is this a chemical change, physical change, chemical property, physical property, or none of the above? So the key here is that it says it's turning sour. So it's a change. So then you have to think, is milk turning sour a chemical change or physical change? Could you get the milk back to what it was before? I know for myself that once milk turns sour, I'm not getting it back, and so I'm just tossing it out. So it must be made into something new. So that would be a chemical change. The answer here would be A, chemical change. All right, you have CuSO4 is dissolved in water. And just in case you're wondering how to name that, you've got copper, you've got sulfur, you've got oxygen. We'll learn naming much later in the year, but it's called copper 2 sulfate. So it's a compound. It's saying it's dissolved in water. So it's dissolved. So that's a change. It's not saying it could dissolve. That would be describing a property. So it's either a physical change or chemical change. Dissolve just means mixed in. It doesn't say anything happened. We don't know if any of the 4 signs of a chemical change have occurred. So your best choice here is a physical change. And copper sulfate dissolved in water is a physical change. All right, aluminum phosphate has a density of 2.566 grams per centimeters cubed. If you remember density, and if that was a chemical or physical, your options still are the changes versus property. Density is a property of matter. You're not changing it, okay? Density is something unique to every substance. So you're not going to look at these changes. So it's either a chemical property or physical property, okay? Remember that chemical properties is something that tells you about something about a substance that could change it. Well, density is not going to change. It's inherent to each substance. So when it's describing the aluminum phosphate density, that's a physical property of aluminum phosphate. Okay, aluminum phosphate has a certain density, and this is what it is. All right, HCl. If you want to, it says being a strong acid. If you want to know how that's named, again, we'll learn naming later. But if you want a little preview, this is called hydrochloric acid. Okay. Hydrochloric acid, being a strong acid, is a blank. Wood sawed into is blank. Okay. So harder one because you've got 2 pieces here. So this first one, you have to decide, is it describing a change or a property? So it says HCl being a strong acid. That sounds like a descriptor to me. So that's a property. So I have to determine, is it a chemical property or a physical property? I would say that it being a strong acid tells you how something could react. So that's most likely a chemical property. But if you didn't know that, you could look at this second one and see, okay, let's see what this is. Wood sawed into is that a change or a property? Well, you're actually changing it, so it's going to be a change. Well, all the options for the second one are changed. It's like, is that a chemical change or physical change? If you're just sawing wood in half, that's just a physical change. You're not changing the wood. So I would say C is your best option. You got a physical property of the acid and physical change with the wood. I hope this video gives you a good introduction and as well as a couple example problems to help you out in preparation for the test, quiz, and labs.